let's evaluate 2 plus x squared y cubed minus y squared sine x over the region that's defined by the absolute value of x plus the absolute value of y is less than or equal to 1. Let's make this vertical bar a little bit bigger here so you can see this is x, y such that absolute value of x plus absolute value of y is less than or equal to 1. Okay, well the first thing I want to do is figure out what on earth does this region look like. So I'm going to start drawing pictures. I'm going to rewrite this as absolute value of y is less than or equal to 1 minus the absolute value of x. I can think that way better. That's the only reason I did it. Okay, so let's do something obvious here. When x equals 0, y equals 1. But that's the absolute value of y that equals 1. So y could be a negative 1 also. Now, when x equals 1, y equals 0. And likewise, when x equals negative 1, y equals 0. So this region has got to look like this. Okay, so how am I going to integrate this thing? Well, let's see. First thing I want to do is write the equations for each of these segments. So this first segment right here is going to be y equals, what is that, negative x plus 1. And this one's going to be y equals x minus 1. And this one's going to be, see, y equals negative x minus 1. And this one's going to be y equals x plus 1. Okay, one of the first things I'm noticing here is that if I write this as a negative x plus 1, this is just a negative of that. And if I factor out negative here, I'll get a negative of negative x plus 1, which is a negative of that. Whoops. Yeah, that's right. So that might be useful. So the first thing I want to do here is I want to take a look at this, and I'm going to break this thing up. So I'm going to take a look at the double integral over this particular region of 2 dA plus the double integral over the region of x squared y cubed dA. Whoops, this is going to be minus the double integral over that region of y squared sine x dA. Well, 2, that should be the easiest, so let's leave that alone and take a look at this for a second. When I'm looking at this region, I'm looking at x squared and y cubed. X squared is an even function, so I could cut the region in half and break it into 2 because it is x squared is symmetric from negative 1 to 1. Y cubed is odd and symmetric from negative 1 to 1, or in this case, these boundaries, these lines. So because it's odd, with that odd symmetry, when I integrate, that's going to be 0. So I don't have to worry about that. Now this piece, y squared is even, so again, just like the x squared, I could break it down. But sine of x is an odd function. And again, I'm going to have that symmetry or reflection, not reflection, symmetry about the origin. So when I integrate sine x, that's going to give me 0. So I can get rid of that. So really, just by drawing this thing and thinking about these functions a little bit, I just made life a lot easier. So all I really need to really be concerned about is this particular region here. Now clearly it doesn't matter which way I go. I'm going to have to break this up into 2 type 1 regions or 2 type 2 regions. It doesn't matter which way I do it. I already have it written in form of a type 1 region, so I'm going to break it up as two type 1 regions. So the first one, I'm going to end up going, x is going to go from -1 to 0. And then y is going to end up going from a negative x plus 1 to x plus 1 of 2 dy dx. So this first piece is just going to be 2y evaluated from negative x plus 1 to x plus 1, which is going to give me 2 times x plus 1 minus 2y, whoops, not 2y, 2 times x plus 1, but I'm going to have a double negative, so this is going to be a positive. So this is going to be 4x plus 4. So now I need to take a look at the integral from -1 to 0 of 4x plus 4 dx, which equals 2x squared plus 4x evaluated from -1 to 0. So that is going to give me, I'll bring this down here, that's going to give me 0 minus 2 minus 4, which is -2 plus 4. That's just going to give me 2. So this first region right here that reaches up to this surface will give me a volume of 2. So now I need to think about the other piece. So I need to take a look at the integral from 0 to 1, because I'm going here in reference to the x-axis. And then from a negative, I'm going to write this as 1 minus x. Switch that around. It looks a little bit better. Up to 1 minus x of 2 dy dx, which gives me 2y evaluated from a negative 1 minus x to 1 minus x, which is going to give me, see, come down here, 2 times 1 minus x minus 2 times 1 minus x, but I have a double negative again. So that's going to give me 2 minus 2x plus 2 minus 2x, which is a negative 4x. Plus 4. So now I need to finish up this last of this integral. So I need to integrate from 0 to 1 of negative 4x plus 4 dx, which is going to give me negative 2x squared plus 4x evaluated from 0 to 1, which is a negative 2 plus 4, which is 2. So this piece also gave me, this piece right here also gave me 2. So that means that my final solution is then simply going to be 2 plus 2 or 4.